A very good afternoon to everyone. A very warm welcome to all the attendees who have joined us today. Once again, I would like to thank you on behalf of Geospatial World for your kind participation in our physical event, plus digital for those of us logging in virtually. I'm Kasirajan. I work with Geospatial World as the industry manager for the AEC vertical. I'll be your host and moderator for this afternoon's plenary discussion on digital construction and digital cities, advancing next-gen geospatial content platform. So earlier this morning, we were audience to the crucial role of geospatial solutions amongst a range of industries and sectors related to improved operations and services in their respective life cycle and value chain. We witnessed our esteemed speakers emphasize the need for geospatial intervention in digitalization of urban infrastructure and construction sites, and rightfully so. For instance, the pandemic witnessed countries across different regions facilitate stimulus packages aimed at infrastructure spending. However, large-scale infrastructure stimulus tends to overlook the basic premise of the plan, and this includes the approaches to implement stimulus package to address core issues and the challenges faced by the particular sector. Public investments need to improve long-term efficiency, reliability, and performance of our infrastructure networks. In this regard, it's crucial to devise an effective asset management plan for public utilities and infrastructure, like water supply, transportation, etc. This will help us assess the performance of the infrastructure and streamline the broad stimulus spending through top-down governance. And such performance assessment is tied to the paucity of accurate granular data at a geographic level, the lack of which results in complicated measures and intervention. As per recent studies, integrated digitalization solutions enable sustainable project delivery performance in reduction of actual project cost and duration by around 30 to 50%. This basically doubles the project returns and cuts energy consumption significantly. The next-gen geospatial platforms are focused on delivering impact on the surrounding environment. This session will focus on advancement of data interoperability capabilities, integrated 4IR geospatial solutions, and sustainable project delivery. Without further ado, I would like to introduce the speakers. Mr. Chris Tucker, he's the Cesium Board of Advisor, Chairman, American Geographical Society. Chris has served as the chairman of American Geographical Society, as well as serves as the board of directors of the Open Geospatial Consortia and US Geospatial Intelligence Foundation. He also serves on many corporate boards and has been part of many public sector bodies. I would also like to introduce Mr. Jochen. He's the head of planning and construction, Autobahn, Germany. Jochen began his professional career as a head of planning department in Bavarian Road Administration. Later, he returned to the chair for the construction of land transportation routes at Technical University of Munich. I would like to request Chris to take us through his presentation. Chris, the floor is yours.
Oh, yeah. Wonderful. All right. Thanks. Thanks so much for having me here today. I really appreciate it. First, I need to send regrets. Cesium CEO Patrick Cozy had an emergency business situation come up on Friday and asked me to fill in for him here. One of the perks of being on the Cesium Board of Advisors is I get to fly to Amsterdam at the last minute for one of Sanjay's wonderful events. I'd also like to just thank Sanjay for making such a wonderful contribution to the world community with your creation here with Geospatial World Forum. It's wonderful to be here with other members of the OGC Board of Directors, Sanjay, and our own Rob Vandervelde. I assume he's here also. So thank you so much. So I'm going to talk a bit about Cesium in the context of digital construction and digital cities. And we talk a lot about these next generation platforms. But as an OGC board member, I was really excited when 3D tiles came out. So I don't know how many of you have ever heard of the 3D tiles specification, but it is actually the core interoperability specification that underpins everything that you're going to see from on the screen from me today. And it's come to play this vital role in the world of digital construction, kind of at every phase of the construction process. And I'm only going to be able to touch on a couple of those phases in the time that I have allotted. Let's see if we go here. The green button, right? Aha. So we actually have an initiative at Cesium working with Komatsu. Komatsu is one of the largest construction equipment companies in the world. And Komatsu's interest really started at the point of looking at site preparation, site development, site engineering. And if anybody's ever been involved in a construction, large-scale construction, they understand how complicated these processes are and how the eye deceives you in every possible way. And many technologies have been rolled out across these sites. We saw lots of great examples from speakers earlier today from Trimble and other companies. And so the question is really, how do you build that kind of digital twin of the site that you're running every day, updated every single day? And Cesium really plays a particular part as a platform provider, using the 3D tiles specification to allow you to stream that data out to a wide range of different applications from many different vendors. So you can think of it as a dynamic process like this, where you're moving volumes, very large volumes of land from one place to another, often within the construction site and often outside of the construction site. We've had to build all sorts of dashboards that take this actual live 3D data as it's sensed across the construction site so that you can manage the day-to-day, the hour by hour, and live sense the change on your site so that you can be as efficient as possible. And do another one. So, as you're preparing a site, you're moving a lot of equipment in and out. That's driving lots of change across that landscape. And every time that you miscalculate, every time you have the wrong piece of equipment in the wrong place at the wrong time, you lose money. And also creates all sorts of construction delays. So, the optimization of this process is really key in having some sort of a dashboard that can deal with the real geospatial change, the real change in materials and volumes, the real change in the equipment in real time is key. Just one more image. I mean, you're talking about continuous change. If anybody's ever been near a large-scale construction site, the number of vehicles, the number of people, the number of pieces of equipment that are not only like moving in and out, but often just misplaced. You're talking about equipment that has daily lease rates that are very pricey. And so you actually need to be able to track this stuff with geographic and temporal precision. Just another picture here. But I figured I would actually go with some videos for the rest of my talk. And I'll talk while they're going on. So there's been a long history of using geotypical data instead of geoprecise data. In building digital twins of our cities. And even, when we've been planning our construction, a lot of it, back in the old days of surveying and doing things on paper, then moved into kind of a CAD BIM kind of environment. But being able to fuse that real time into our actual landscapes and understand the change live in our landscapes has been a real evolution in our industry. What 3D tiles has really enabled is the ability to not only track those changes, which you can do in many pieces of software, but then be able to live stream out all of those changes out to the most meager edge device, an edge device that has very little compute on it at all, and be able to not only be able to do this at the desktop or at the headquarters, at the engineer, or with the architecture, with the architects, but be able to do it down all the way to the mobile device of the site foreman and in the vehicles themselves, and increasingly in the automated hardware that is running across these sites. So there's all sorts of things that you can do once you can stream that data to the edge, and you can stream it into a wide range of environments using geospatial standards in a standard way, right? You can get all sorts of interoperability across your different software packages, and you can go everywhere from kind of site site preparation to the full site build, where you're dropping in the CAD BIM models that you develop as an architect, all the way through the as-built, and be able to monitor that over time, streaming it out to a web browser, and all the way down to those devices. So it's really about kind of this dynamic change and the ability to monitor that in real time, and even into an augmented reality or virtual reality environment, so that you can, I'm not at the site today, but I want to be able to take the exact geo-precise data that represents the site as it was left today, bring it into the environment, assess it, and be able to give the best orders and do the best business planning. So this is another video with one of our partners, Aerometrics, and this is using gaming engines. So one of the interesting things here is we have this collision with 3D tiles. We have this collision of geo-precise sensing with the proliferation and commoditization of a wide range of sensors. We have this kind of collision between that and things like gaming engines and what we're increasingly calling the Metaverse. So this is built on Unreal Engine. If anybody knows Epic Games' Unreal Engine, using the Cesium, what we call Cesium native, we've been able to build into what we call Cesium for Unreal. And this is modeled data, right? That's not an actual human that we sensed in there, but you're able to take a detailed building and drop it into the precise location in the city built from geo-precise sensed 3D models into a gaming engine where you're able to play out a wide range of modeling and simulation scenarios. The basic ones, right, are what will the sun and the shadows look like in an urban canyon when I add this new building there. Sometimes that's increasingly a thing that goes through city permitting, and you have to actually answer those questions. So, well, and here, we're talking about the actual siting of buildings in kind of a concrete scenario, and you realize, that the actual layout and configuration of those buildings can have consequences for all of the neighbors and the effect of the space. So I'll skip and go on. There we go. So just to make a few last points, and I'll sit. One is, we're adding about 80 million people to the planet each year. People they think about construction as, yes, I'm going to build a building, but we, as a global community, are adding the equivalent of 10 New York cities or 1 Germany to the planet every year, right? In terms of the number of people. Those people have to grow up and everything, but if you think about shifting age cohorts, that's what's happening on our planet every year. More than 75% of that much larger population is going to be urban by 2050, right? So a large proportion of the human population now isn't urban, a little less than 50%. That the total population is going to grow, and then they're going to move into cities. One more reason why this is really paramount, that we get this really efficient, really effective, so that we can have very sustainable and thoughtful and strategic construction going on. These next-gen geospatial platforms for managing the full life cycle of a city, city development will be required. It's no longer just, designing a building, pulling the permits, getting it built. It is the full life cycle. It's being strategic about the built environment that we're creating for these additional 80 million people every year. The investment in digital construction will actually ensure that we have digital twins that we know that we need, right? I mean, digital twins aren't something, there's some cities, wealthy cities, that are able to kind of go and build a digital twin. It may not be as deep as you think it is, right? Because it doesn't have all of the as-builts. It doesn't have everything that was done that makes that city work. It's typically, much more of a superficial kind of way of addressing things. It is the actual process of doing this for a couple decades, right, where we're doing full-on digital construction and building these out in great detail that will give us, that will yield these digital twins that we know we need for a wide range of kind of smart city functions. There already are standards from OGC, from the Open Geospatial Consortium, from the Khronos Group that enable such next-gen geospatial platforms to stream this data out to the edge, to share it across many different vendor platforms, to provide the kind of interoperability that we all say that we know that we need. Some people look at that and say, well, this stuff is too complicated. And I know, I've been in this industry for 20 years, and when I started, it was all points, lines, and polygons over here, and bad rasters over there, and some CAD BIM over there. And we all kind of looked at it saying, well, there's no real way all of that's going to be able to come together. And it turns out now with the dawn of 3D tiles, GLTF, and other related standards, we actually have the building blocks at our disposal to go forward. And it's not just that we have the standards, but we have massively scalable software platforms at our disposal that use those. So, I leave you with the metaverse. A lot of people hear that buzzword out there. We talk about digital cities, we talk about digital construction, we talk about digital twins, and increasingly we find ourselves in this currently rather fractured kind of metaverse, but we have all of these digital representations that increasingly we are living in, whether it is through an augmented reality kind of world, a virtual reality kind of world, a mixed reality sort of world. And without those standards and the ability to bring in the actual world itself, the geographic data of our actual lived experience into these metaverses, there are always going to be this kind of virtual space. Think kind of Second Life and other places we go to interact online. But now that we can bring the entire world in at geo-specific high accuracies into this process, we have the opportunity to have a fully interoperable metaverse through the entire process of kind of the human existence, of building out the human existence, not just running through a city, as it's envisioned in some archetypical way, but every moment of every day, all of the change across our ever-growing cities as we keep adding people to our planet endlessly. So I think I'll leave you with that. If you do have any questions on how Cesium thinks about it, Dave Bragg, dave@cesium.com, he'd be more than happy to take your inquiries related to this stack of technology. So thanks so much.
Thank you, Chris. Thank you, Chris. That was really insightful. In fact, I was part of the lunch break with Chris and another fellow speaker of ours, Anthony. Shout out to Anthony. And I was witness to a really amazing conversation in terms of the Unreal Engine and the gaming platforms coming together to increase the simulation capabilities of city development going forward. Exciting times. Without further ado, I would like to extend my warm welcome to Jochen, and he'll go forward with his presentation. Thank you.
Yeah, thank you very much. I'm happy to give you a little report fresh from the workbench and little insight into a project we have done the last year. And we tried to take point clouds and derive CAD lines out of these point clouds. And I will give you some insight why we did this and how we did this. Just to give you a little impression why I'm here and why I'm talking to you and for which organization I'm talking. I'm a member of the Autobahn, a German infrastructure operator with 300 locations nationwide and quite a large network of motorways in Germany with 13,000 kilometers and estimated asset value of about 200 billion euro. So this is quite a lot of stuff to manage. And I'm in the branch of South Bavaria with a network of about 1.5 thousand kilometers. And I'm head of the planning and construction division. So working with a lot of projects. The Autobahn is not only planning and constructing the motorways, but we are also in operation and maintenance and also having a look on the finance aspects and the management, the overall management on the motorways. But coming back to the workbench, what we are doing normally to start a project is, you can see here the 4 times the same motorway junction with a picture taken from a drone. Nowadays we are using laser scans for surveying the motorways, the existing situation, and then deriving in a manual process the CAD lines, the information about the as-built situation or the as-built model if we are using BIM. And after doing this or working together with consultants, we get a CAD plan that can use as a basis for the upcoming planning. And what we wanted to do is put more efficiency in this process. The challenge we're looking at is we're having about 500 projects only in my branch, and an investment volume of about 8 billion euro. We are lacking the information of the inventory, the situation as it is today, and often quite old plans back 30, 40, 50 years ago. So these are not having a consistent basis. And the traditional way for surveying is quite cost and time intensive. So we were thinking about a new way where we can reduce the time and the cost and the effort to start a project, and also try to improve the quality. And the idea was what can be done to reduce the manual share in this process. And the vision was, is it possible to take a point cloud as we derive it from a laser scan or from some other sources, put it in the black box in the cloud as a software as a service solution, and derive the CAD files or maybe also the BIM objects, the models, and the information that's interesting to start the planning. This was the vision, and we decided to start with a proof of concept if this is working. And we started with a first approach together with partners and tried an automatic classification and labeling in the point cloud, which was working, but it didn't deliver for example, what we tried to do in this proof of concept, it didn't deliver the edges of the motorway, the concrete pavement in the precision as we wanted it to have. So we tried another approach, and second approach, and used a deep learning approach, and took the existing material, the existing data for 5 kilometers of motorway, and put it in the system as a training data. And the result was really interesting, really good, as we were able to get quite good results on deriving cut lines in an automatic process from the point clouds. So we went into a partnership with a surveying consultant, with a team from developers, software developers, focusing on artificial intelligence, together with the Bavarian State Ministry for Housing and Mobility, together with the Autobahn, and bringing together all the knowledge that was necessary. And we proved that it's possible to detect the outer edges from the motorway, and generate also in an automatic process the CAD lines. And the preliminary results were quite promising, that it will be possible to improve with further learnings, with further data, that we can optimize the process. But already the proof of concept results were really good. What do we believe that we will get from this? We see that we will benefit from first aspect, that we can accelerate the approach. We can accelerate the way to start a project. believe that we can reduce the costs. Today, the laser scan is not, most times it's less than 1,000 euro per kilometer for the laser scan, but the manual process for delivering the CAD files is 10 times higher. And we believe that we can cut these costs down to lower than 1,000 euro per kilometer. And this will help to start the projects. And we believe that it can be even like maybe a game changer for using data, as we can generate data quite easy, but it's hard to work with the data at the moment. And we believe that it will foster new approaches and new use cases that can be that can work with this data that can be derived from this approach. Just some ideas what we are thinking about the use case we believe that we can work with this approach. One possible use case is noise mitigation. We are having new regulations in Germany for noise mitigation. The threshold for noise mitigation was lowered some months ago, and probably we will have to recalculate 1/3 of the network, and we need some input data. We need the geometry of the motorway, but we also need the exact height of the noise barriers, and we don't have this information in the moment. So probably we will need an efficient way to get the input information for recalculation for noise calculation, noise mitigation. We see that it's a good input for planning, for starting a planning project. And we also see that it is a good input for asset management, for use and maintenance, use in operations, but also for the administrative use. For example, quite a lot interests are putting solar power systems quite close to the motorway, and there's always the need for data for this. So these are the use cases we are thinking we will go for the next months, the next years. So far from my side, and we are now looking for the questions.
Perfect. Thank you, Jochen. Thank you both, gentlemen, for your really insightful presentations. Really appreciate that. I'm pretty sure our audience appreciate that as well. I would like to open the forum for any questions that the attendees, the audience might have. If there aren't any, I would proceed with my questions. Any questions at all? Yes, please. Yes, sir. You can use one of the mics over there.
Hello.
Hi.
Yeah, I'm Mr. Prashant Daladgi from Pune, India. We are one of the oldest LiDAR kinematic scanning companies using mobile LiDAR since 6 years. My question was for the latest slide, which says that automation is required for feature extraction from the point cloud data for edges, point line, polygon features. Why don't we use the ready-made, easily available softwares in market, which are capable of extracting the features automatically? We have done 20,000 kilometers of LiDAR surveys for highways in India, but we found their manual method to be most effective because the edges are not sharp there.
Right.
But here in European countries, we can use the ready-made softwares which are available in market to map and extract the features.
Yep.
That was my question.
Thank you. Thank you for your question. Jochen, I believe it was directed towards you. Is there any particular reason why you had to customize your own solution for making sure those edges are classified accordingly? Or were there any shortcomings or challenges that were associated with your other softwares that you might have used?
Yes, we are not heading for the one solution for this approach, but we wanted to know if it's a feasible way of approach at all. So we went for this proof of concept.
Yeah.
Because we didn't see a way to do it in the process we tested during the proof of concept. In the next step, we want to challenge the market, so not going for one solution, but be in an open approach, saying what we want to do. For example, start with 100 kilometers of motorway and say what features have to be detected. And the challenge for the market will be in which approach it can be done most cost efficiently or time efficiently. Probably the cost will be the most important part when coming to public procurement. So our idea is to say we now believe that it is possible to do at least a partially automatic approach, probably not for 100%. We see that not all features have enough training material in the existing manually labeled and derived material. So we know that the edge of the motorway will probably be feasible, but some certain features that are existing only 2 or 3 times in that will need manual processing.
Right.
And we will open it for the market, and maybe it will end in a only manual process, but I think that it will be a combination of manual and automatic process.
Right. Thank you, Jochen. I hope that answered the question. Due to the sensitivity of time, I've got one last question, and that's for Chris. Chris, I heard you use a really interesting terminology. It was geotypical data versus geoprecision data. Can you maybe elaborate a bit further on these two and their role in digital cities and digital construction going forward?
Yeah, for sure. I only go back about 20, 25 years in this space, but there used to be a huge divide between having real geospatial data that we used in GIS and surveying, and then the things we could put into a modeling and simulation environment. It was just this massive chasm. So you had to create all of this geotypical. It looked real. It was beautiful to the eye. It was good for training on, but it actually didn't necessarily represent the real world accurately and precisely. Right. And now, we're seeing with the commoditization of all of these sensors, the proliferation of all sorts of phenomenologies, LiDAR, photogrammetric, et cetera, are giving us the ability to get the level of precision. I think that's a great example. You saw the Autobahn using. That it no longer has to be geotypical. So there are still certain things that, power lines, we don't do really well with LiDAR, certain linear features. So when you want it to be represented in your modeling simulation environment, there's still, some tuning you want to do if you want to get the edges sharp on a building, et cetera. But I think what you're going to see over the next handful of years is, now that we have the ability to stream real geospatial data into these environments with 3D tiles and other specifications, you're going to see us, in effect, give up kind of the geotypical and end up with just real strong representations of everything.
Right. Great. That's a perfect way to sum it up. I believe that brings our closure to the next-gen geospatial content platform. We believe there is a crucial role to be played by all these advent of technologies, both in terms of the Unreal Engine and the integration of all these different technologies put together, and make sure the level of digitalization is almost 100%, so that there is a level of project transparency, there's a level of accountability, and you finally have a sustainable asset lifecycle. Well, thank you so much to the audience and the speakers.